So, model with mathematics. An object is thrown from the height of 5 inches. After 2 seconds, the object reaches a maximum height of 9 inches and then it lands back to the ground 5 seconds after it was thrown. Write a vertex form of the quadratic equation that models the object's path and draw the graph. So first of all, let's try to draw a graph here. As we see in here, an object was thrown from 5 inches. Let's say here is 5 inches is here. And let's say this is a signifies h of t, the height of the thrown object. So this is the h, this is the height. And here is the time. It says for how many seconds it was on the air. So now what it says here, after 2 seconds, the object reaches a maximum height of 9 inches. 2 seconds is here after 2 seconds, but it reached 9 inches the height. So this point is here. And then it says the maximum height. So the maximum height, we already know, it can be the vertex of the parabola. And this is 2, because 2 inches, and I'm sorry, 2 seconds and 9 inches is the vertex, 2 and 9. So now we are looking here and it lands on the ground 5 seconds after thrown. So it lands, it means the height is 0 when it lands on the ground, so it doesn't have any height. And time is a 5 seconds, so is right here. And now we can graph the function. This function here, we can graph, we can sketch now the parabola of the graph of that function, and it goes down and goes up to here. Okay, now this is the vertex, and now what we are looking for, we are looking to write a vertex form of the quadratic equation that models the object's path. Okay, so now we are looking here, I have 2 points. One point here is a 5 and 0. So after 5 seconds, it means the height is 0. One of the point is here when intersects the parabola x-axis. And y-intersect here is 0 and 5. So I already have 2 points. 2 points, I can use either one of them. But I need just 1 point in order to find the equation and the vertex. And now we already know the formula for the general form of a quadratic equation. Vertex form is y is equal with a x minus h square plus k. We already know this formula, plus k. And now what we are doing here, we are going, let me do one step at a time, and we are going to plug here, instead of I don't know exactly what it is, a vertical stretch or compression. And here I'm looking, x is x. And let me write here, h is 2, because this is h, this is k. We already know that. And is 2. And this is a square. And instead of the k, I have 9, plus 9. But now I have to choose one of the points. I'm choosing this point. The coordinates of this point are x and y. X is 0 and y is 5. So I have these 2 points. And now I'm going here to change, to use it. I'm sorry. If I'm using here those coordinates of this point, I have y is 5. So I'm substituting here 5. And this is equal with the a, because I want to solve for a. I don't know what it is. Instead of the x, I am plugging here 0. And here is a minus 2 square. So everything here is square, plus 9. And I'm looking what's going to happen. So here is a 5. So this doesn't have any changes. But here 0 minus 2 is 2. 2 square is 4. So it means a 4a. So is equal plus 9. So what I'm doing here, minus 9 both sides, I'm going to use minus 9 this side and minus 9 the other side. And this cancels. So what remains here remains a minus 9 plus 4 is minus 4. So it's a minus 4 is equal to the 4a. So now I'm dividing everything by 4. If I'm dividing everything by 4, it means a is going to be minus 1. So everything I'm dividing by 4, and a is equal with minus 1. So we found a is minus 1. And now we have this equation. An equation here is a y is equal to the minus 1. Minus 1 times this expression here, I get this expression, so I don't have to write the 1. I just write the minus sign, and the invisible 1 is here. And is x minus 2 square plus 9. So we already found the equation. But because here is denoted the y coordinate is with the h of t, and the x-axis is with the time t. Now we can write exactly with the exact denotation the height of the ball t, of the object t. In fact, this is an object, we don't know what it is a minus, instead of the x I am writing t, because of this function the height is with respect to time, and whenever it's x I'm substituting with a t, and here is a square plus 9. So this is the final answer. Even this answer here is okay, but this one is more official for this case.